Let's talk about the end of Moore's Law. One of the best ways to describe what's happening is to follow along with what Dr. David Patterson is doing at UC Berkeley. He's an architect as well for the TPU, which is a TensorFlow processing unit. And what he says is that the undergrowth of single program speed really occurred, right around this period of the last 40 years, right? So at first in the 1980s, there was this 22% increase. Once the RISC processor was around, we got a 52% increase. Then things started to slow down a little bit. And you can see here right around, let's say 2003, there's a 23% growth rate because multi-core machines come in and they're not as efficient at scaling things, right? Because you're going to lose efficiency due to Amdahl's law. And here we see Amdahl's law, which effectively says the parallel portion of your code has diminishing returns. Finally, you get to current, which is about a 3% increase. So there's some big problems, but it creates opportunities. So one of the ways that people are taking advantage of this dead end is to look at ASICs, and these stand for application-specific integrated circuits. And a good example of an ASIC is something that many people already have on their machine is a GPU, and specifically things like a NVIDIA GPU. There's been a whole toolkit designed around it to do parallel coding. And that toolkit is called CUDA. There's other vendors that are starting to jump in and get involved and compete with the CUDA infrastructure like AMD. Also, there's new players like TPUs, which are actually even going beyond what a GPU does and specifically generating workloads that work with, let's say, the TensorFlow machine learning framework. So here's an example of a TPU in production for Google, started in 2015. They use it for search, for translation, for photos. You can see a whole rack here. Now, what's the difference? Well, a CPU is really designed to do a lot of different things. So it's a general purpose processing unit. Now, if you look at a GPU, though, it's been specifically designed to do things in parallel, really. And that's the big difference between a CPU and a GPU is designed to be parallel, where a CPU is really designed to do lots of different things and execute different things on a computer. Now, if we look at a TPU, one of the things that's interesting is a TPU is even more dense than a GPU, and you can see that a TPU is actually doesn't even care about doing only parallelization. It's focused on parallelization for a specific workload. So really, this is one of the advantages of these ASICs is that you, as maybe a software vendor, you could control the whole stack, and you could actually design something that works with the software you have, the cloud you have, and also the processor you have.